From the dawn of time, humanity has gazed up at the stars and wondered about our place in the cosmos. We have always been explorers, driven by a deep-seated curiosity to venture into the unknown. Among the celestial wonders, Mars, the red planet, has captivated our imagination for centuries. Named after the Roman god of war, Mars has long been an object of fascination. Its reddish hue, visible even to the naked eye, sets it apart from other points of light in the night sky. For centuries, astronomers have meticulously tracked its movements. With the advent of telescopes, we began to glimpse tantalizing hints of its surface features. Today, thanks to decades of robotic exploration, we know more about Mars than ever before. We have rovers traversing its dusty plains, sending back stunning images of vast canyons, towering volcanoes, and ancient riverbeds. Mars is not just another planet, it represents the next great leap for humanity. It is a call to adventure, an invitation to embark on one of the greatest journeys in human history, the establishment of a permanent human colony on another planet. Reaching Mars is no easy feat. The red planet at its closest approach to Earth lies some 34 million miles away. The journey to Mars will be long and arduous, lasting anywhere from 6 to 9 months. During this time, our astronauts will be confined to the cramped quarters of their spacecraft, exposed to the hazards of deep space. Cosmic radiation poses a significant risk to human health. Shielding our spacecraft and developing effective countermeasures to mitigate radiation exposure will be paramount. Maintaining crew morale, fostering teamwork, and providing psychological support will be essential to ensuring their well-being throughout the long journey to Mars. Upon arriving at Mars, our astronauts will be greeted by a world both hauntingly familiar and strikingly alien. The red planet, though once home to flowing water and a thicker atmosphere, is now a cold, dry, and desolate place. Its thin atmosphere, composed primarily of carbon dioxide, offers little protection from the harsh radiation of the sun. The Martian surface is scarred by ancient impact craters, towering volcanoes, and vast canyons. Temperatures on Mars fluctuate wildly, from a balmy summer day at the equator to a frigid winter night at the poles. Gravity on Mars is about 38% that of Earth's, which means that while our astronauts will be able to jump higher and lift heavier objects, they will also experience a gradual loss of bone density and muscle mass over time. Understanding the long-term effects of reduced gravity on the human body is crucial for planning extended stays on Mars. To survive the challenges of the Martian environment, we need to create a home away from home. A habitat that provides our astronauts with the protection and resources they need to thrive. One promising approach is to build habitats using Martian resources, a concept known as in situ resource utilization. By utilizing materials found on Mars, we can reduce the amount of cargo we need to transport from Earth. Martian soil, known as regolith, can be used to create bricks or other building materials, while water ice found beneath the surface could be extracted for drinking, growing crops, and generating rocket fuel. To protect against radiation, our habitats could be built underground, utilizing natural caves or lava tubes for shielding. Alternatively, we could construct above-ground structures with thick walls made from regolith or other radiation-resistant materials. Inside, our Martian habitats would need to provide a comfortable and functional living environment for our astronauts. Vertical farms, utilizing hydroponics or aeroponics, could grow fresh produce, supplementing the astronauts' diet and providing a welcome touch of green in the otherwise barren landscape. Essential to the survival of any Martian colony is the development of robust and reliable life support systems. The Martian atmosphere is incredibly thin and composed primarily of carbon dioxide, making it toxic to humans. To create a breathable atmosphere within our habitats, we'll need to employ advanced life support systems that can extract oxygen from the Martian atmosphere or generate it using other methods, such as electrolysis. Water is another precious resource that will be essential for human survival on Mars. While recent discoveries have confirmed the presence of water ice beneath the Martian surface, extracting and purifying it will require significant energy and infrastructure. Water recycling systems will be crucial for conserving this precious resource. Growing food on Mars will be another challenge. By cultivating crops within controlled environments, such as greenhouses or vertical farms, and supplementing the Martian soil with nutrients, we can create sustainable food sources for our Martian colonists. To establish a truly sustainable presence on Mars, we must learn to live off the land, utilizing the planet's resources to meet our needs. This concept, known as in situ resource utilization or ISRU, is crucial for reducing our reliance on Earth. One of the most valuable resources on Mars is water ice, which can be found beneath the surface in many locations. This ice can be extracted and purified for drinking, hygiene, and irrigation. It can also be split into its constituent elements, hydrogen and oxygen, which can be used as rocket propellant or combined to create energy. The Martian atmosphere, though thin, can also be a source of valuable resources. Carbon dioxide, the primary component of the Martian atmosphere, can be used for plant growth in greenhouses or converted into methane, a versatile fuel. Three-dimensional printing technology could be used to create complex structures and tools, using Martian regolith as a building material. Establishing a permanent human presence on Mars is not just about escaping the confines of our home planet. It's about ensuring the long-term survival of our species. By becoming a multi-planetary species, we hedge our bets against existential threats such as asteroid impacts, pandemics, and climate change. Mars is also an ideal proving ground for developing technologies and strategies that could be used to explore and settle other celestial bodies in our solar system and beyond. The lessons we learn on Mars, from developing sustainable life support systems to utilizing in situ resources, will be invaluable as we venture further into the cosmos. The challenges of living on Mars will also drive innovation and technological advancements that could have profound implications for life on Earth. From developing new energy sources to creating advanced medical technologies, the quest to colonize Mars has the potential to unlock countless technological breakthroughs. But perhaps the most compelling reason to colonize Mars is the indomitable spirit of exploration that burns within us all. The desire to explore, to push the boundaries of what's possible, is woven into the very fabric of our being. The journey to establish a self-sustaining colony on Mars will be fraught with challenges, but the rewards are immeasurable. It will require a global effort, uniting the best and brightest minds from all corners of the globe. We must develop sustainable life support systems that can provide breathable air, clean water, and nutritious food for our Martian colonists. We must master the art of in situ resource utilization, extracting and utilizing Martian resources to minimize our reliance on Earth. And we must develop advanced technologies for transportation, communication, and exploration that will allow us to thrive on this alien world. But the most critical factor in the success of any Martian colony will be the human element. We must select individuals who are not only highly skilled and knowledgeable, but also resilient, adaptable, and possess an unwavering sense of purpose. Establishing a permanent human presence on Mars is about extending the reach of human civilization to another planet, creating a new branch of our species that will carry the torch of human ingenuity and exploration into the future. The colonization of Mars marks a pivotal moment in human history, a turning point that will redefine our place in the cosmos. It signifies a shift from a species confined to a single planet, to one with a presence on two worlds. As we venture further into the cosmos, we will encounter new wonders, new challenges, and new opportunities that will test the limits of our understanding and push the boundaries of human potential. The colonization of Mars is not the end goal, but rather the beginning of an extraordinary journey of discovery and exploration. It is a journey that will inspire generations to come, igniting the imaginations of young minds and fueling the fires of innovation and progress. The future of humanity lies among the stars. Let us make it a future worthy of their dreams, a future where humanity thrives not just on Earth but among the stars, a future where the red planet becomes a beacon of hope, innovation, and the indomitable spirit of human exploration.